The wrench slipped in an oil-slicked hand as a middle-aged captain stared at the bomber in front of him and realized, with perfect clarity, that he was looking at a crime. It was early March, 1943, on a rough field at Port Moresby, New Guinea. In the humid heat stood a B-25 Mitchell that no manual had ever described, no blueprint had ever approved, and no headquarters in Washington had ever authorized. Where a bombardier's glass nose was supposed to catch the light, there was metal. Where clear plexiglass should have been, there were 8 dark muzzles of 50 caliber Browning machine guns, all pointing straight ahead. That bomber was not a medium precision weapon anymore. It was a ship killer, and the man behind it, Paul Irvin Pappy, Gunn, had broken almost every rule in the United States Army Air Forces to build it. On paper, Gunn was a captain, a technical officer attached to a far-flung theater that Washington considered secondary. In reality, he was something quite different. A 40-something former Navy chief, a pilot since the 20s, a man who had crashed, rebuilt, and flown aircraft long before many of his superiors had ever left the ground. He was also a husband and father whose wife and 4 children were behind barbed wire in Manila. That last fact mattered more than any rank on his shoulder. 2 years earlier, on December 8, 1941, Manila time, Gunn had watched Japanese bombers erase American air power in the Philippines in a single morning. He helped keep a collapsing defense alive for a few brutal weeks, flying reconnaissance and emergency transport in civilian Beechcraft that had been impressed into service. He dodged fighters, flew into surrounded airstrips with medical supplies, and earned a distinguished Flying Cross for courage that most people only read about in books. But he never reached his family in time. Orders pulled him out to Australia. Japanese troops closed in. His wife Polly and their children were swept up and pushed into the internment camp at Santo Tomas. After that, everything Gunn did in the air carried an extra weight. He was fighting a war for his country, but he was also fighting a private war for 4 children who were learning to grow up behind bamboo and bayonets. Faith could steady a man's hands. It could not armor steel. So Gunn did the one thing he knew how to do better than almost anyone. He changed the machines. When Lieutenant General George Kenney arrived to take over Allied air forces in the Southwest Pacific in mid-1942, he found a command that was losing the war by arithmetic. High-altitude bombing against ships was producing hit rates so low they might as well have been zero. Flying fortresses dropped tons of explosives into empty ocean, while Japanese convoys slid along the sea lanes and fed garrisons in New Guinea. Ground troops bled in the jungle. Because shipping, not courage, was winning. Kenney had spent years thinking about better ways to fight. He understood that in a world of limited aircraft, the only number that really mattered was kill rate per sortie. How many ships did a squadron actually remove from the enemy's order of battle for every mission flown, every crew risked, every gallon of fuel burned? If that ratio stayed low, no amount of bravery could change the outcome. Conventional doctrine was failing. The data made that brutally clear. Then Kenney heard a rumor. Somewhere in his theater, a captain was quietly ripping bombardiers out of aircraft noses, welding gun mounts, and turning light bombers into flying buzzsaws. Instead of court-martialing him, Kenney got in a jeep. What he found in the makeshift shops at Townsville, Australia, was organized heresy. A-20s with solid noses and banks of forward-firing guns. Ammunition chutes improvised from scrap. Mounts scavenged from wrecked fighters. Gunn and a handful of enlisted men working 18-hour days, test-firing, adjusting, and then taking the aircraft up themselves to make sure they held together under recoil. Gunn did not have an engineering degree. What he had was something harsher. 2 decades of hands-on experience and a mind that treated every sortie as an experiment. How close could a bomber get before flak became mathematically suicidal? How many guns did it take to strip a ship's deck bare in 3 seconds? At what distance should 8 weapons be harmonized so that their streams of bullets converged into a single, invisible saw blade? The answers did not come from theory. They came from tests on real ranges, on real aircraft, with crews holding on as whole airframes shuddered under the weight of metal. Leaving the barrels, Kenney looked at the results and made a decision that separated him from more cautious commanders. He pulled Gunn out of the shadows and made him his special projects officer. From that point on, the Southwest Pacific became a laboratory. The logic behind the B-25 conversions was ruthless and simple. A standard Mitchell had been designed for medium altitude, level bombing, with a glass nose for the bombardier and a handful of defensive guns scattered around the fuselage. Against maneuvering ships, that concept was failing. Bombs dropped from thousands of feet up took long seconds to fall. In those seconds, even a slow transport could shift enough to turn a perfect solution into a miss. Less than 1% of bombs were hitting. At that hit rate, the kill rate per mission was catastrophically low. The math of defeat was already baked into the tables. Gunn turned the problem upside down. If bombs from above could not reliably find ships, why not bring the bomber down to the ships? If gunners on deck were the real threat, why not give the bomber so much forward firepower that it could erase those gunners before they had time to aim? He stripped out the bombardier's position. The glass nose went away. In its place came a solid structure packed with 50 caliber Brownings, each with 500 rounds ready to feed. Cheek guns were added beside the cockpit, their barrels poking just ahead of the propeller arc. The dorsal turret, originally meant to protect against fighters above and behind, was locked to face forward so that its twin guns could join the storm. 8 guns in all, under the pilot's fingertips. When they spoke together, they could throw roughly 180 pounds of metal into the air every second. Tracer lines turned into an unbroken stream of fire. That kind of power did not come free. The nose grew heavy. Center of gravity shifted forward. Recoil tried to twist the airframe off target whenever the triggers were pulled. Gunn worked through each problem like a mechanic mathematician. Equipment moved aft, braces added, structural weak spots reinforced. Guns were test-fired on the ground, then adjusted again. He established harmonization ranges, 200 yards for some missions, 400 for others, based on what tactics and training proved safest and most lethal. It was engineering by feedback loop, build, test, record, adjust, repeat. The machines were changing, but so were the men. Crews learned to fly at heights where a mistake of a few feet meant hitting a wave. Pilots learned to think not in abstract altitude, but in mast height, funnel height, eye level with the bridge. Technology alone did not create that change. Training did. Drills did. The hard experience of crews who came back with flak scars in the wings and bullet holes in the fuselage did. While this quiet revolution in metal was underway, another quieter revolution was happening in radio waves. By late February of 1943, Allied codebreakers in places like Melbourne were reading enough Japanese naval traffic to understand when something big was moving. In messages pulled from the ether and decoded in fluorescent-lit rooms, a pattern took shape. A major convoy was forming at Rabaul, headed to Laos with thousands of troops to reinforce the desperate fight in New Guinea. 8 transports, 8 destroyers, nearly 7,000 soldiers. That was not just a tactical movement. That was a strategic bet. Once again, the math took over. If that convoy reached Laos intact, those troops and their supplies would extend the campaign, bleed more Allied divisions, and by Tokyo time. If the convoy could be annihilated at sea, those same men would never fire a shot in anger. Tons of ammunition would never be unloaded. The future casualty lists on both sides would change. Air power could not afford to harass that convoy. It had to erase it. Kenney understood that the battle was going to be as much about information and procedure as about hardware. Reconnaissance aircraft were tasked to maintain contact through bad weather. Command posts tracked positions, bearings, and speeds on plotting boards. Attack groups rehearsed on derelict ships, flying mock profiles at mast height, and practicing the timing of skip bombing until it became a kind of deadly muscle memory. Training ranges were suddenly full of aircraft coming in low, guns ripping at old hulls, then dropping practice. Bombs at carefully measured distances so that crews could see with their own eyes how far ordnance would travel across the water before impact. Pilots learned to read wake patterns and estimate closing speeds. They drilled formation approaches so their fields of fire would overlap just enough to suppress defenses without colliding. It was all data, distances, angles, delays in seconds, before fuses armed and detonated. The kill rate they hoped to achieve at the Bismarck Sea would not be an accident. It would be the product of this grim arithmetic. On the morning of March 3, 1943, the weather finally cleared. The Japanese convoy, already battered by days of mostly ineffective high-altitude attacks, was still largely intact. 8 transports, 4,000 to 5,000 men still aboard, for destroyers untouched, for more damaged but afloat. They were within a few dozen miles of La. The Allied strike groups assembled over Cape Ward. Hunt, flying fortresses up high to distract and split the defenders' attention, Royal Australian Air Force Beaufighters low and fast to rake decks with cannon fire, P-38s overhead to meet the swarm of expected Zero fighters, and Gunn's B-25 strafers ready to come in at wave-top height. From the Japanese bridges, the first sign that this day would be different was not the sound of bombs. It was the sight of aircraft coming in far too low. The Beaufighters went first, their 20mm shells gouging ships from bow to stern, killing gunners, chopping up light flak positions, shredding rangefinders, and driving crews away from their stations. Then the Mitchells arrived. Each pilot had already memorized his part. Approaches were flown at roughly 50 feet above the water, closing in at speeds that left Japanese gunners with only a few seconds to react. At about 1,000 yards, the B-25s opened fire. 8 streams of 50 caliber rounds stitched across the surface and climbed onto decks, marching through gun positions, crews, and bridge superstructures. It was mechanical but not impersonal. Inside those cockpits, men could see other men die. The purpose of that fire was not to sink. It was to silence and blind. Only once that was done did the physics of skip bombing take over. At 200 to 400 yards, pilots stabbed bomb release switches. 500-pound bombs dropped, hit the water at well over 200 miles per hour, skipped like stones, and slammed into hulls just at or below the waterline. Delayed fuses allowed them to penetrate before detonating. When they did, the surrounding sea itself became part of the weapon, transmitting shock into steel with ruthless efficiency. In less than an hour of concentrated attacks, the kill rate figures that planners had once dreamed about became real. Every transport was either sinking, burning, or dead in the water. Destroyers lay broken or afire. Follow-on strikes in the afternoon hunted down survivors and finished off cripples that had tried to crawl toward land. By nightfall, all 8 transports and 4 destroyers were gone. Thousands of Japanese soldiers died within sight of land they would never reach. Only a fraction of the original troops would ever set foot on New Guinea, many without weapons or equipment. For the Allies, the losses were almost shockingly light. A handful of aircraft, a handful of crews. In crude percentages, the exchange was brutal, an entire convoy wiped out for the cost of what, on paper, looked like a bad training day. They did not just lose a battle. They lost their idea of the world. For Japanese naval officers, the lesson from the Bismarck Sea was not simply that Allied pilots were brave or that new tactics were clever. The lesson was that within range of land-based airfields, daylight convoys had become suicidal. Even strong escorts and air cover could not keep low-flying bombers from punching weapons into the sea at ranges where there was simply no time to react. In other words, the kill rate per sortie had leapt from a few damaged ships for dozens of missions to something close to annihilation of the target set in a single coordinated effort. Gunn's transformed bombers were at the heart of that shift, but they were not its only cause. The intelligence centers that tracked the convoy, the meteorologists who forecasted the break in weather, the ground crews who kept temperamental engines running, the armorers who wired fuses to the right delays, the instructors who had drilled pilots over and over on skip bombing profiles. Each of them fed into that final 40-minute storm. Technology had changed the shape of the B-25. Systems had changed the shape of the war. The months that followed turned those once improvised illegal modifications into standard practice. North American aviation engineers visited the theater to study what Gunn had done in crude workshops and translated it into factory production lines. Strafer variants like the G, H, and J models emerged, bristling with guns and, in some cases, mounting 75mm cannons in the nose. Some of those refinements went too far. Cannon-armed versions were heavy and awkward. Loading the big gun was slow and dangerous. In combat, center of gravity problems made takeoffs and landings more treacherous. In stateside test centers, cautious officers recommended grounding or redesign. From the front, Gunn's response was blunt. The The aircraft worked where it mattered, in combat. Pilots learned the quirks, flew accordingly, and kept using them because, for all their flaws, they still put metal on target in quantities no enemy convoy could absorb. Perfect engineering was a peacetime luxury. In wartime, good enough to kill reliably was the standard that mattered. Throughout late 1943 and 1944, Mitchell strafers ranged across New Guinea, the Bismarck Archipelago, and eventually the Philippines, smashing airfields, barge traffic, coastal shipping, and any concentration of Japanese logistics they could find. They became a kind of flying blockade, turning miles of ocean into killing grounds where every sortie had a measurable cost for the enemy's order of battle. Abundance, not ideology, won the war. Abundance of aircraft that could be modified, abundance of fuel, abundance of ammunition to feed batteries of 8, 12, or even 18 guns in the nose, and waste of a single medium bomber. That industrial depth was what allowed a grieving father, a flexible theater commander, and a network of anonymous mechanics and gunners to turn one illegal idea into standard practice across an entire fleet of nearly 10,000 B-25s built. Even then, the war did not make clean heroes' arcs. Gunn himself was badly wounded when enemy bombs hit Tacloban airfield during the liberation of the Philippines. Shrapnel tore into his shoulder and arm, injuries that would end his combat flying even as Allied troops pushed closer to the camp, where his family had spent more than 3 years as prisoners. When elements of the 1st Cavalry finally broke through to Santo Tomas in early 1945, they arrived just ahead of a planned mass execution of camp leaders. Behind them came medics and logistics units that had learned from long practice how to stabilize starving civilians. Among the liberated were Polly and the children, emaciated, changed forever, but alive. The reunion with Gunn came later, in Australia. The war had not given him back the years he had lost with his children. It had not erased the injuries that would ultimately force his retirement as a medically unfit full colonel in 1948. But it had, in its own harsh way, kept the promise his improvisations had been trying to keep from the beginning, to shorten the war enough that his family might survive it. After the guns fell silent, the B-25's legacy extended far beyond Pacific geography. Air forces around the world studied what had happened at the Bismarck Sea. They noted the way forward-firing armament had turned bombers into gun platforms. They traced a line from those Mitchell strafers to later gunships, AC-47 Dakotas circling over Vietnamese valleys, AC-130 Spectres firing into jungle clearings, modern aircraft that kill primarily with guns and guided projectiles rather than gravity. But in all those later doctrines and manuals, something essential sometimes got lost. Gunn's illegal B-25 was not just about hardware. It was about refusing to accept bad numbers. As long as bombers were hitting less than one ship in 100, the men in those aircraft were, in his words, dying for poor odds. Change the weapons, change the training. Change the way information flowed from codebreakers to flight lines, and that ratio could be turned on its head. That was the lesson the Japanese commanders took away when they admitted, after the war, that the Bismarck Sea ended any realistic hope of sustaining major forces in New Guinea by sea. That was the lesson Allied planners absorbed when they began designing post-war air fleets around the idea that air superiority over a theater's logistics was more decisive than bombs on cities. The story of Pappy Gunn and his ship killers is easy to frame as a tale of one maverick engineer defying bureaucracy. In truth, it is a story about something more complicated and more unsettling. How personal loss can drive ruthless innovation. How a single theater can become a proving ground where kill rates, not slogans, decide which ideas live and which die. It is also a reminder that the men on the receiving end of those B-25s, sailors on Japanese transports, soldiers packed into holds, gunners staring up at dark specks against the sun, were just as real as the crews inside the Mitchells that destroyed them. They were trapped in a system that could no longer protect its own logistics, outproduced, out-innovated, and increasingly outflown. The roar of twin Wright radial engines over an airshow crowd today, the sight of a restored Mitchell banking low over a runway, the flash of blank charges from modern replica gun packs. All of that is a faint echo of what happened in those few minutes over the Bismarck Sea. In that space between sea and sky, one man's refusal to accept bad odds, one commander's willingness to back an unauthorized idea, and one theater's hard-won lessons in training, intelligence, and coordination converged into a single, lethal equation. The result was not just ships sunk or tonnage lost. It was a shift in how wars would be fought whenever air power could see and reach an enemy's lifelines. In the end, the story of that illegal bomber is the story of what happens when necessity, grief, and data all point in the same direction, and somebody is stubborn enough to follow them there. They did not just build a weapon. They rewrote the math of survival on the sea.